instructions. And
Why is no one here?
huh?
Why is a lot of people not here?
Because Carrie got Sweet 16, Ava is in the traffic, and who else are they? Oh, Matthew is in.
Shadow was in Chicago.
Yeah, Matthew is in Chicago. Yes, so that was kind of sad. Um, yeah. So what I'm gonna do is I'm gonna ask you to think about this. So first of all, let's just start from before. We start from x squared plus y squared. Um,
That's a
is
circle.
Yeah, it's a circle. We're gonna do a circle, so it's less than 4. So that's gonna be within the circle. And I don't know how to draw dotted line. Actually, they don't get to decide. I don't know why you don't get to. Oh,
Hey,
because
but
equal to, because greater equal to. Yeah, so I'm a dummy. Okay, so then that's a solid line. So we put a restriction like what we did before. We say we're just playing with it. We're just playing with it right now.
oh, that's what I used to do a lot.
Okay, yeah. So today it's just a fun class. It's not like no math class, and I know you guys all like Zoom tire out and everything. So we're not trying to create a class that is. So we're gonna say y is less than x, and
Oh,
so that's gonna become a half a circle, and we say we can add a perimeter. A is a slider, so we can make it a circle. Move back and forth, just kind of like what's that pirate ship? It's called pirate ship. What's that thing on the like fairgrounds?
that made it look better. Like, you make it like the middle a hollow circle, so instead of like less than 4, it's less than 4, and it's like it has to be more than something.
Yeah, yeah. So you can do whatever you want. We just talk about what kind of creativity is out there, and how do we make it a circle move. So earlier we talked about this
Smiley
one.
face.
We talk about is minus h, so we can make the circle move.
I'm gonna make a parentheses.
Yeah, that's what I'm gonna do. Don't forget, it's hard to do with.
No, you make y also make y negative h. It looks weird.
So
You also do y to 2 minus h. Like y to the second power minus h. That looks very weird.
yeah, you can do whatever you want. It's up to you. Um, and
That's
that
heard of this before.
and that way that this circle is constantly moving now. Where the circle goes. Wait, the circle shrink.
Oh, it's like an it's not that's not how a sunrise works.
Yeah, but we no, we are playing with things. So
Here.
the problem is that this circle disappear, and we don't want to do that because the problem is that restrictions y is less than ax, and the problem is that a is constantly moving. A is just the slope of the function. That's why it's decide which side to shade inside the circle. And so we need a restriction on this one. So it's pretty much I need a parenthesis here. I need to say y minus h, right? Minus h, minus h, just like a y minus y1 equal to x minus x1. Um, so we're gonna talk about that.
I did the x factorial graph. That one looked weird.
Yeah, that's cool. But what we want you to do is actually design something. Like we want you to not just do a cool graph. We want you to use what you know to design things. So,
What things?
oops. Oh, Jesus. You know what? I'm gonna do it on a computer instead because I cannot do that very quickly. So let's try this again. Do it on desktop.
Ow.
Um, and so
Imagine going to Chicago. Chicago is cringe.
so we got x parenthesis x minus h, and square plus y minus
Multiply.
k
What happens if you multiply?
square and less than 4, and we add that. That's a circle, and with a restriction. So we want a restriction to be y minus h less than a parenthesis x minus k.
Okay, perfect.
And add a. So now it's moving around. So the problem of that is we gotta set t is equal. So May says, can I make the circle move? So now this one should be able to follow something's still off. I don't know where. Because that's supposed to rotate. It's not supposed to be disappear. I don't know why.
It doesn't set K, it doesn't set T.
Oh, I didn't set T. Okay, let me do that. Let me get rid of that. But that's still, that should go within the circle.
Plus, right? Plus.
Okay, so anyway, we're gonna set T equal to H, and f of t is equal to K. Ft equal to K. That didn't work. Now K equal to F. K equal to F of T. I don't know why that works. That doesn't work, so let me pause this. So T is equal to 9.2, so T equal to H. H equal to T, sorry. H equal to T. I don't know. So maybe we do it in terms of A and B. Maybe let's do that.
Oh, we do H equals to T, then it doesn't know what T is.
Yeah, but what we're trying to do is we're trying to make them run to the thing. So yeah, that's what you guys need to try different things and to see how it work. B, and we're gonna do this one is a C then. So add a slider A, B, C, D. That's too many damn slider. Okay, so let's try A equal to T, and B is equal to F of T. Nope, it doesn't work. Why is that? Add a slider, maybe?
Oh, see, I know why. Let's try to set B as something else already. It can be B like that.
What'd you say?
You can't do B like that. You can't do that. You have to remove the slider of B. I think.
Remove the slider of B?
Yeah.
But I want a B to move though.
That I don't know how it works.
X minus A, y minus B squared less than 4. And y minus A less than ax minus b. That's fine. And
let me try something else. I'm on Desmos myself.
You can try. Yeah, so you guys are more welcome to try. So I want you guys to come up something that is very creative. And you can open canvas to draw anything, right? So I don't want to restrict you to a certain thing. So let me go back to see how this part is done. Maybe we can find out what's wrong.
Okay, that's not right. Oh, I think negative A, negative B.
So A is equal to T, B is equal to F of T. A is equal to T.
Oh, square root. How do you do square root? Probably that's why. Please announce. Square root of B. What is it?
I think I need to a equal. I need a parenthesis a comma b here in order to work. Let me try. Let me try that.
Why doesn't that work?
Where's my graph go? Did I save it? Nope. Let's try again. So let's just try a minus x minus a. Plus y minus k. And then square.
Oh, I know why.
Is less than.
Alright, now I did it.
Okay. So what did you find out?
I did something. I made a dot in the middle of the circle, just moving the circle around and drag it wherever I want.
Yeah, that's one of the things that you add a
So
slider b.
it has to be b comma a. It has to be b comma a. I think. Oh, never mind.
No.
Oh, I did it opposite. I did it wrong. Wait.
A comma b. Oh, so now I can decide a is equal to t, b is equal to f of t. Wait, why is that I cannot do that anymore? You define a in more than one places.
Oh yeah, because a is equal to t, but a is also equal to negative 0.1417. Basically, you're saying t equals to 0.17.
Yeah, that's okay because I wanted to have f of x equal to x squared.
But you have to do it like b equals to f of a. Then b equals to f of t.
Okay, then you show me how to do it. See if you can do it right.
Well, remove the red line.
Remove which red line?
The red one.
This one?
And then made it b equals to f of a.
It's f of a.
And now I was thinking mine should work, but this.
It's still not working because
remove a comma b. Maybe to see that if that works. Remove a comma b.
A comma b is needed though.
Huh. I think this entire system is flawed.
But it worked here. It worked on the other side. So let me see why it worked on this one, but it's not working on that one. So this is so this one is define the ocean. This one is define the sun. This one's define the A and B is the label is movement. A is equal to T, B is equal to F of T. So they define it twice.
I don't think the restriction works. I don't think I can do the restriction.
Oh, but I didn't do a restriction. I didn't do a restriction on the other one.
Copy and paste it there. See if it works.
Good question. So let me copy. Well, I don't know how to copy.
You just did it. No. Go back. No, go back to where you were. The setting thing.
Okay.
It says copy and paste. Like the two things.
This one? Duplicate? But they only duplicate every line.
Then just copy and paste it. Like copy and paste into like a Word document or something.
I don't think I can do that.
I have a screen. Wait. I have a screenshotted. Oh, it says t equals to blah 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 at the end. It says t equals something. It never said a equals to something. It says t equals to something. It doesn't have like a equal to 1 or a equal to 2 or b equals to 2. It says t equal to 2. Go back. I know what's wrong.
Okay, let's go back. Let's go according to what you say. Obviously, I did not save that, so you know what? Let's save that project today.
Yes.
Today.
Project moment.
So we want to what May want to do is we want to make that.
Like a circle, yeah.
We want to make that circle move in the circular motions. So that's what she want to do. So we're gonna try that.
I know how to do it. Now.
Okay, if you know how to do it, then you can show me too.
Why did you do 2 X's? It's supposed to be Y.
What?
It's supposed to be Y minus B.
I can type.
Yep, and then remove a equals to 1 and b equals to 1. Remove that.
Yo, no, that's just a slider.
No, remove it. You have to. And then do a.
Do a comma b.
No. Do a equals to t.
T.
And then b
equal to f
equals
of t.
to f of t. And then go no. Go down. Do t equals to. No, so just add slider for t.
Add slider for t.
And now it should work. Oh, I think the f. No, you can't. I don't think you can do f of t. You have to like go to like the manually. You have to go to the keyboard. You look at the bottom of this keyboard up. You can't do that. No, go there.
I don't know actually.
No, I know why.
Wait, what just happened? It did. It did follow the line. Look, it did follow the line.
But it's not doing it correctly. Wait, can you like remove that?
It's doing correctly if I do it.
Oh wait, yeah.
Yeah, there we go.
It's just going up now. Wait,
okay.
Can we see it? Can I like scroll out?
Okay, so almost there. So we just had to make a circular motion now.
Make it a circle. F of x equals x. X squared plus y squared.
No. Yeah, but you.
Oh, wait, you need to do the circle a different way.
Yeah, the circle is gonna be kind of hard.
Try it. Let's try it. Maybe it works. Plus y squared.
No, it doesn't work that way.
Maybe try it. Maybe it works.
It doesn't work. Yeah. Because you have 2 y, you have 2 f of x, right? So
I don't think you have to do s. You have to do.
So why don't we do is equal to 9, and we got x squared plus this square.
Oh, that could work.
That didn't work. Okay, so we can make a square. I don't know how do we make a circular motion. May, I'm sorry, I'm disappointing you.
Oh wait, I think I have an idea. Oh wait, I have an idea. Yeah. Do f of x again. F of x equals to b.
F of x. Oh,
not b. Like
equal to b.
Not b like another thing like m or something.
M.
And then go to
No. I think I have an idea. I can write circle in different way. So the circle in different way is square root. Okay, so square root. Let me see square root. Square root of 4 minus x squared. 4 minus x squared. So it's running. But okay, so almost there.
I don't think. Oh, make the circle like bigger, just a little bit bigger. Oh, can put the circle up. Like make the circle go up. It doesn't go down the negative line.
Hold on. So, damn it, May, you give me a tough task.
We have an idea. Maybe like do square root of 4 minus x minus 5 x squared. Do that. I think that will work.
No, that won't work. What the heck are you talking
Try
about?
it. I think it will work. Like,
okay, actually. What happened? What'd you say?
Go to the x squared part.
Mm-hmm.
Go make it x parentheses.
Like this.
X minus h.
Not h.
No, make it 4. Make it like 5 or something. make it 5. No, make it 5.
Why 5? Why 5?
Oh.
Why just moving the circle to outer red?
Make it B. Make it B.
B is a y value.
Try it.
It didn't work. So we can make a half circle right now. We just cannot make a whole circle. So let's make the circle a little bit bigger. 16.
Was it another way? Can you have a circle?
How do we make it rotate all the way on a circle?
Oh, you could do like f of x plus 2 or something. F of x minus 2. Well, let's move. Like 2 f of x. Try that. Or like f of x minus 2. But not in the parentheses. F of x minus 2. Try that. I think that will work. Hopefully.
How about you try it and you send it to me if it work?
F of x.
Okay, anyway, there's so many things you can play with. I remember one of my students did a disco line, which is kind of interesting. Which is he just pick random point and just create disco line. So that's what he did, and it's a very simple coding. It just use y, it's like y minus h is less than m times x minus k, but you just pick a point, so it'd be 2 and let's say 3. Okay, so and then add a slider for m, and he got y minus 2.
Wait a minute. I did something.
Okay,
No,
share it with me if you got it done.
I don't know how to share screen. Can't share screen. Yeah, share screen. Can you like make it allow so I can share screen?
No, I'm gonna show you like how one of my students did a disco line. So it's basically using m like this, using the idea of a y minus y1 equal to m times x minus 1, and all establish the same point and play the same m. Is gonna create like a kind of disco light effect.
Do a lot, like copy and paste it, because 1,000.
Yeah, so you can do that. That's what they did. That's what she did. But she just had to change the different points. So you can create another point that says 5, 8, and 5, 8.
And then make it restricted, make the domain restricted to a spot.
So that becomes like a pretty cool effect.
The colors change because of like which one's above and which one's under. Cool.
I don't know. How do you decide that?
It just does. Yeah, I did something. So can you go back to the graph that I did?
You can share with me. Just share it and put on the Zoom link.
Can I just how what? What do you mean?
You can share the graph. Like, look, you can share. Like, click this button, and share the hyperlink.
Okay, I don't know. I was just experimenting and I have this.
Okay. May, I'm sorry I disappointed you. I don't know how to do that yet, but maybe Samuel can figure out.
It's okay.
But something. You see the things can be eliminated, right?
So I have an idea.
Okay, let's look at what Samuel did. Let me see.
I did it.
Samuel.
I did something. Wait. I shared. I'm gonna share a different link. It changed.
Okay.
I did something. I don't know if it works.
That did not move the way.
No, that's just an extra thing. Look at the bottom part. I made a circle with like 2 functions.
Oh yeah, that's easy. That's not hard. But the problem is they're not gonna go by the same thing. They're not gonna go by.
Let me like domain.
Oh, you did not set. You did not set. I know what you're saying, but the problem is the circle cannot exist at 2 different paths.
Maybe you can make it like a domain restrictive, so like as soon as it passes that part, it changes to a different thing.
That's actually a good idea. Okay, let's try that.
That would be extremely. There's a simpler way to do it. Of course there are, but like.
Wait, you gotta do a equal to t, right?
No, just
And the
experimenting.
t is b is equal to. Wait, why you switch? Oh no, you didn't switch. B equal to f of t. F of.
You're not doing it right.
B equal to f of t.
And then remove the A and B slider.
But b is still not defined. Why is b not defined?
Remove A, comma B. Oh, you haven't defined T yet. You need to define T too, like T equals.
There's no slider for t. Why is there's no?
Make one, like T equals to 2. Just
No.
make us on a new thing.
You cannot. But anyway.
Go down. Go to the one that's 7. Go to
Okay.
7.
Samuel, go ahead. Keep on working on it, and we'll figure out together. But I want you guys to try different things now and to see what you come up with, and just share it here. Just share your link and share it here. So that's the whole idea. Now you know how to graph radical graph. You know how to graph square root graph, square root. The all this function can be transformed. So for example, like if you have x squared, right? Y equal to x squared. Then if you want to move at certain places, you just take it to h, and you're gonna put it minus h, and put a parenthesis here, and then that you can move the parabola, depends on where you're going. Okay, so that's just the movements, but most of the artistic part is just, graph lines and stuff like that. So I want you to come up with different things, and we had to see creativities and stuff like that. May, are you working on it?
Can I just start working on the stuff for the competition?
Sure, yeah, you can start.
I still don't know how to make the circle spin.
What is circle spin? What do you mean circle spin?
Like, you said, like, if it was, like, y is greater than x, then you, like, put the a, you do x times a, and then you add a slider for a, and it spins the circle. But, like, what if it's a 0?
Oh my god, you made something that scares me.
Okay, what did you say?
I made a thing.
What did you? No, hold on a second. What did Samantha say? I'm gonna try to answer Samantha's question.
Like, usually, like, if it's like y is greater than x, you do x times a, and it can, like, spin, the circle spins.
Mm-hmm.
But, like, if you do 0 is greater than x, then the circle, like, won't spin. So, like, how do you make it spin if it's 0?
Why do you want to make it 0 and spin, though? That's my question.
Well, because how do you, like, well, can you make it, like, half a circle without it being 0?
You
Half a circle
you can make a half circle by solving for y. So that's what we just did earlier. So
a big brain idea. I just had a big brain idea.
Okay, so 4 minus x squared, and that is gonna be the oops. That doesn't make sense. So let's just say if I wanted to do y restriction, so y is greater than 0.
What?
Okay, so this is a half a circle. How do you want them spin?
Like spin it counter or clockwise. I don't know. Either way.
So you want to make it like a wheel?
Yeah, like a wheel.
Oh, that's why you say you want a to be infinite. Is that what you're saying?
Well, so it needs to spin, but like not completely, like only like 45 degrees.
Yeah, because a to infinite, it doesn't make it rotate. Okay, so I have a graph that might help with that one. Let's see. The spin one, this one. Okay.
What the?
So this one is spins.
Oh.
Okay, but
Okay, and let's see what it did. How do they make it
okay,
spin?
how does the circle in the middle? Like the circle in the middle, how does that one spin?
This is beyond. This is beyond. It's this is like have high mathematics skill and creativity. So let's figure out. Which circle is this? Let me see. So this is the left, right circles, bottom circles. Okay. So do you want me to share this graph with you?
Oh, sure.
Let me share copy, and we're gonna go with stop sharing chat. I share this one. It's a circle that can spin. So that is a shade. That's a shade.
Oh.
The H.
Oh.
Where's the H? Oh, B is equal. Oh, B is equal to H pi.
You're not sharing your screen.
Oh, let me share my screen. Sorry. That's not. That's
I think the same. Can you like explain to me this?
Okay, so hold on a second. Let me share my screen first. Zoom.
Oh, okay. What is that?
Share screen. And share desktop. There we go. So they make B is equal to H pi. And they spin the H. And they will go backwards.
Is it just like is it just spinning?
So let's make a line spin first.
Try H squared pi. Make it H.
Oh yeah, I also need to know how to make a line spin. How do you make a line spin?
Huh?
How do you make a line spin?
It's something to do with this part. So H is the slider, and then they go with B is equal to H pi, and then
Why pi?
Because pi is circle.
It's circle, yes, but
I
how?
thought we're making a line spin.
Yeah, but where's the line though? What the heck is the line? This is the line? Oh yeah, this is the line.
Why is that the line?
Magic.
That's in order to make it a line spin. So
Bro, what?
I don't understand either. You're it's fine.
yeah, so no, this is okay. This is okay. This is actually yeah, this is a little bit beyond me what I can do, but okay, well that's not too bad. So you make this line and spin. So T is between negative 3.414 and negative pi over 4. So
why that specific number?
what'd you say?
Why 3.4152?
That's
It's pi.
no,
No, it's
that's
not.
3.14 is pi.
What? It is different. Oh, there's a 2. Oh, that's a 2. Oh, I don't know.
Yeah, so this is definitely beyond what I can do. So
Like at my graph, I don't know what I did.
but I don't think that you guys should think that complicated just for now, because right now we just want you to use all different function. So the rubric is gonna have is, can you use all the functions? Well, for example, can you use square root x graph? Can you use circle graph, rhombus graph? Can you use any kind of graph? So this is using in a way
Wait.
that this might be using polar equation to express the circle. Um,
Oh my goodness. Oh my god. Oh, I made something that looks really weird. It's spinning so fast. Oh my god.
okay, so right now I want you to create a graph with a purpose, some type of drawing and some type of functional things. So you guys have open canvas to do it. So if you have something, share with me now. I want to look at it.
Maybe like check what I did. I don't know what I did. I made like something.
Yeah, but you're not understanding that thing that you created. There's a difference because you just type
Oh,
in.
I do understand it. I don't know how to proceed from there.
Like this one is just a simple idea to make things work. Now to create the line is rotating. I think there's a way to do it. Hold on, let me figure out. We just want to create a line rotating. So right now, so
You so that's how you, if I know how that works, you can make a circle. But this is following a parabola straight motion. Eventually it'll reach, like, doesn't make sense, but it does. Ooh.
hold on.
Oh. Wait a minute. Well, that's also a problem. This should follow a waterfall. Huh? Okay.
So that's gonna make this okay. Um. Okay, so the ideas I want you to be able to do is come up some type of drawing ideas, and so here we can see on Desmos. You're not supposed to copy other people's lines, but you can see other people's work. Um, here's what other people did. Oops, my bad. You don't have to create animation. Animation just part of the things. So this is what I want to see if you guys can do is they have a global math art competitions, um, and this between 13 and 14. So they
There's
did.
no way. There's no. I can't compete in that. There's no way I can like even get placed.
You don't have to be placed. I just want you come up with something that is original ideas, not copying other people, of course. So here's other people's ideas, right? So you got this person probably did. It's actually pretty cool. Um, so this is one of the idea that they have. So this is all the finalists. Um, and if you go into you know if you go into even harder stuff, that this is other people's drawing, which is it has nothing to do with animations. So we don't have to do anything about animation. We just had to do something about what you can come up with drawing using lines and stuff like that. Animation is way beyond the skill of like you had to be truly very very um, mathematically inclined to do those things, which is way beyond what I can do, and it's not something that you can learn right away. But this is just a basic art skill from the people who did it. So this is one of the things that they draw. They have a lot of drawing, and they have very 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 cool stuff, which is here. This is actually pretty cool. Um, but you had to be extremely patient to do that. But you don't have to do that. Just you need to come up with some type of creativity, um, to draw something or come up with something. I have I'm gonna start my competition next week for my pre-cal students, and I can't wait. They have unlimited this. You don't have to do any animation. Animation is way too difficult um, for me to teach you.
I saw
Actually,
the time one. It was so cool.
which one?
The time one right there. It's like the one on the right, next to the portrait.
Next to portrait. Okay, let me see.
Oh, just experimenting. I didn't see it.
This one seems like impossible.
Wow.
Can I see the clock and the window in the room?
I'm surprised this one didn't win.
I have no idea how you would make that.
I'm surprised this one didn't win. This one should have won. This one's much better than the other one. They even have a light.
Can I see the other one?
Huh?
Can I see the other one?
Yeah, other one's not as good. Like this is a finalist, right? And the person who won the first prize is this one. Now this is very detailed, but I think the other one's way more creativity.
How did they make this? Tentacle 1, tentacle 2?
Yeah, they will tell you. They will tell you what they did.
How do you make folders? How do you like make that caption thing?
How do you do polygon? Blah blah blah.
This one you had to search up how they do it. I have no idea. You had to search up because you can actually search up all the functions.
Arcsin?
Arcsin, not Arcsin.
Arcsin.
Arson.
Arson.
It's Arcsin.
Yeah.
Baby tentacles? Okay. That
So
was hard. Oh.
so this, you can see this is the second one.
Image?
Oh, this is a drawing. Wow. Well, this is pretty though.
What does it mean by image? Image, blah blah blah, RPG. We're gonna remove everything.
The image is she fill in the color, and it's an actual image. This is actual image file, so it's not a drawing.
What it did, it That must take time. Minecraft's easier.
You can draw Minecraft if you want. It's,
I can make if I have the time and the skills. I will make a full application of Happy Skywalk.
you
It
can
will
do
take me years, like millions of years, to do the spawn.
you can do whatever, but
I was planning on making a crafting table for memes.
crafting table. Okay.
I'm gonna show you Happy Skywalk. I am on Happy Skywalk right now.
This is really pretty. I don't know how she do that. It's very alive. So students' creativity is unlimited. Like they think about this is actually where a student is gonna do 1,000 times better job than a teacher can ever do, because student can come up with those things, and
Because teachers aren't big brain and students are.
yep, that's true. I have to say this one's very cool. I've never seen this one. This is the first time I've seen this. And with the rat going from one side to the other side, it's crazy.
The rat.
Huh?
How did they make the rat?
It just ellipse in the line, I think.
Oh, it says mouse. Can you like click on mouse, the folder for mouse?
Sure.
Oh.
It's a circle. Not really a circle, it's an ellipse.
Oh, if he added more, if whoever made this added more detail to the room, probably would have won.
I think that it doesn't need a detail. I think this is definitely a creativity.
It's the creative. It's the most creative one I've seen.
Yeah, and it's
it's not. It's impressive, but it's not like. It's not screaming at your face art.
well, this not everybody's artist, right? So
Not all art.
yeah, not
Yeah.
every like a lot of those people are literally are artists, and this person's really implement the animation in there, so which is probably very different. Very
What's
very
a
different.
student? It says student.
Huh?
Yeah, it's a student.
So his name is Ray
Student
Agner.
California, USA. It's the one next to Ray, the student.
That's just a self portrait.
Oh.
Yeah,
I thought it
this
was
is okay. This is not that bad.
Parabola, 69 table rows. 69, really? Oh, yeah, let's go. That must take some time.
Yeah, but probably I think the other one is better. So
The
this
room
one's
is actually
okay.
pretty fun. Who won?
The top three, this person won is from Oregon, and this is actually a really good starting night.
Oh, second place looks cool.
Yeah, this is cool. But take a while to load.
It's too cool.
Take several minutes to load.
Oh, okay.
I have to say
Can we
this.
see like 17, 18-year-olds?
Sure.
Oh. Nice.
I like the snake though.
The snakes probably took a lot of time.
Yeah.
That is sick.
I could make that in Minecraft.
And I feel like when they got older, it's kind of not as creative, I think.
Well, can I see the number one? Okay. Desmos bar. Oh. The fact that they made us 3D, that's impressive.
Yo, what is that? How is that even possible? What?
How did they make the D? Why did I do that?
They render in this
What
mode.
the heck?
I'm about to drink some mud.
I'm about to drink some mud. How did they do that? That's...
Create 3D rendering Desmos. Let's check it out.
I'm bored and the current challenge on the Desmos subreddit is in 3D, so let's make a 3D grapher from scratch.
Desmos subreddit,
Disclaimer,
huh?
I have no idea what I'm doing and haven't the slightest clue how 3D graphics work. Okay, so you know how if you have a cube and it spins, the points kind of form a circle shape? Let's start with that. We can create models in cylindrical coordinates to make stuff easier for us and some sines and cosines later. We now have one axis of rotation. This is kinda cool, but it mostly just sucks, so let's get another axis of rotation. Okay, so to make this cooler, you know how if you look down, you're just stretching out the circle that the points move around? Well, let's implement that. Now we have our circles getting stretched out, but that's not very realistic. Something's missing. That something is that when all of our circles are fully stretched out, they should be on top of each other. Meaning we need to change the height of the circles. That's pretty easy, just slap a cosine next to h and now we have two axes of rotation. Now we could go for 3, but I'm lazy and 2 is enough for me. Now we run into another problem though, and that's that we're graphing this orthographically. What does that mean? Well, basically, if we look at this black circle, is it in front of the blue circle or behind it? How about now? Exactly, you can't tell because objects closer to you are the same size as objects further away. This can be useful in some context, but I don't like it, so we're gonna make this a perspective 3D grapher, which means that closer objects look bigger. Here's a cool visual to demonstrate the difference. So to create the illusion of perspective, we just need to take what we would expect with perspective and stretch it out to orthographic. This means we need to determine the z of a point, or how close it is to the camera, and scale it accordingly, so let's do that. Okay, so here's the function for how you do that. How does it work? Basically, this part adds how close the point is to the camera based purely off its height, then this takes into account the rotation and radius. Now that we know the z-coordinate of our points, we can create a distance slider and multiply everything by d over d minus the z position of each point. It actually works, and since it uses trig instead of lists and sums, it runs fast. That's about all I have to say, so have some cool visuals before the video ends.
Huh?
Click on music.
What the?
Okay.
This is illegal. It violates the laws of life, of reality. It violates the laws of reality. It's illegal.
The sinus. Oh my, that's not right.
That is pretty cool.
Is that the cap? Oh, wait, click on that black point. that's sick. That's so pog.
I have to say this person's a genius.
He said it all like so casually, and I had no idea what he was talking about.
That's YouTuber stuff.
Yeah, but he's not even has a lot of subscribers. But I guess nobody will watch this type of stuff. But it's very cool. It's very interesting.
He should play Minecraft.
Sell online and grow your business with Wix e-commerce. Create a beautiful.
Okay.
Okay, so what is this and how does it work? Before we can cover that, let's go back in time a bit. Enter October 14th. I was sitting in calculus doing derivatives work and I got this problem. Nothing too out of the ordinary. I took the derivative of it and decided to graph it just to see what it would look like. For some reason, I decided to zoom out of the graph. Slowly my screen filled with red, but then something peculiar happened. Just for 1 second, my graph looked almost like it hadn't zoomed out at all. It still behaved strangely, but it looked completely normal. Even weirder was that you could get into this weird state just by adjusting the size of the graphing window. Not only that, but sometimes if you move the graph, it would actually become animated. That was beyond strange, but I already had a basic intuition of how something like this may come about. Let's look at this visually. When you think of how a graphing calculator would work, you think of inputting every number within a viewing range into a function, then plotting every output as a continuous function. This is in theory how graphing calculators work, but not necessarily in practice. Realistically, graphing calculators don't have enough time to plug in an infinite number of values into a function, so they cut corners and only plug in numbers over a reasonable interval. This interval could be anything, but usually it would make the most sense for it to correspond with something like the number of pixels on a screen. For example, if we had a 10-pixel graphing calculator, we would only get the value of a function 10 times to graph it. This method works perfectly for 99% of cases, but there are a few fringe cases that can trick the calculator into incorrectly displaying a function. Remember that our calculator only takes a measurement every pixel. This means that it doesn't care what we do in between each measurement. For example, if we were to have a sine wave that repeats it exactly every pixel, it would just be graphed as a straight line. This is cool and all, but our graph isn't a straight line, so how does that work? Well, watch what happens when we change the period slightly of our sine wave. I just want to pause for a second to really give you an intuition of what's going on here. If we look at each pixel individually, you can see that the sine wave almost looks the same. Just as we move from pixel to pixel, the sine wave shifts slightly to the side. This is because the pixel width and the period of the sine wave are slightly offset, meaning that for every pixel, the sine wave shifts slightly by this offset, creating the illusion of animation. This animation is what we see on a larger scale being applied to create a larger graph. Okay, so now we know how to get the illusion of a regular function, but that still doesn't explain why the graph becomes animated whenever we move the screen. While this is more speculative, I do believe it's due to a similar effect, where there's a slight discrepancy between the conversion of pixels from moving our mouse and units offset by the graph, causing the graph to appear at a very close but slightly different position as you move it around. Great, so we've established how the effect works in this scenario, but can we generalize it to more? Yes we can. All we need is a function that has a matching period to the screen width and that has each frame of animation stored within it. To create something like this, we can set up a function of x and k, with k representing time. Then all we have to do is input x for x and x times the sample rate mod 1 for k, with the sample rate being the scaling factor to align the period of our graph with the pixels on screen. So that's it. It works, right? Well, only kind of. It works for me, but not for hardly anyone else, because everyone has different screen sizes and different browsers or computers that would render the screen slightly differently. Remember that being even a pixel off can completely break the illusion. To fix this, I set out on a long and painful quest to find the correct scale to line up with our sample rate for every window resolution. We're pretty much done now. If you type this into your URL bar, the width of the graph will be adjusted for your screen size. Before I end, I want to add a side note that if the units moved for dragging your mouse and the units of the graph are synced perfectly, it won't appear animated, but you can fix this by changing your screen size and rerunning the script. That's all for now. I'll link the graph in the description if you want.
This is cool.
I understand anything he said. That's insane.
I'm gonna subscribe this guy.
The sales process can be a long and windy journey.
Calculus class, you know?
Sell online and
But I'm gonna subscribe to him as well.
You know how smart this guy is? This guy is probably smarter than Professor. That's how
That is
smart.
who plays Minecraft for a living.
That's how
Okay, no.
intelligent this guy could be.
I play Minecraft every day for no reason. Well, there's a reason, but there's actually no reason.
So they are actually very good at create illusions.
Yeah.
I'm bored in the current shop.
And the way he does it is pretty impressive.
I'm bored in the
sell on.
So he's the one that did the card? No, he's not the one that did the card. But how do we come up with this?
I'm
guy?
bored in the current challenge on the
How did we come up with this guy?
I'm bored in the current challenge on the Desmos side.
Sell on. The sales process can be a long and windy journey. HelloSign helps you get every contract signed much faster. It's the quickest way to electronically send contracts or any document.
A few days ago, I posted a proof of concept Desmos graph where you could play a short Geometry Dash level. After getting a lot of positive feedback, I decided to make a follow-up project where I would use my own assets and creativity to make a game. I would build up suspense, but that takes effort, so here it is. I've named it Rocket Dash because it's almost a Geometry Dash clone, but with slightly different mechanics and graphics. The main idea of this video isn't to be a showcase of my game, but rather a summary of how I made it in hopes maybe you can make something better. First step was graphics. Instead of using expressions to make a game, I decided to use images to reduce lag and make it look better. First, I introduced 4 different layers of parallax for my background and made them move based on a variable. To make sure the background couldn't go off screen, I used modulus expressions and lists to create multiple instances of the image and have each one loop back. For character images, I decided to handle the character and rocket separately, but have them both inherit the same position and rotation. The character has 3 states of enthusiasm, based on the current speed he's going, and the rocket has an active and inactive state. You can probably guess what those are based off of. This looks pretty good, but it could look better, so I decided to add a screen shake. To do this, I made a variable to store the camera as a point and positioned my existing assets relative to that point. I then defined the camera, including a shake point, which was just based off a slider as the seed of a pseudo-random number. I also decided to scale the shake quadratically based off your current speed to make it feel like you were actually moving. I also applied the shake twice to the rocket for some extra effect. Next, instead of implementing the core gameplay loop, I made a cool speedometer. Now that we have that out of the way, time to make the character actually move up and down. We can create a variable that controls the y of our character and increment it based off of a variable for our velocity, which is based off our speed. Normally, you wouldn't be able to create autonomous variables in Desmos, but by setting a regression, then using the regression term to define the limits of our variable, we can squeeze our way out of that restriction. Now that we have movement, all we need are obstacles in a collision system. We can stack our tiles and use pseudo-random numbers and modular expressions to generate points that our obstacles should be located at. For collisions, we can get all towers at a similar x to our character and make sure our character's y is within the gap of our towers. Finally, we can set up a similar regression system to control our position, that way we can regress back to the start of our course if we collide with any object. Now we have our finished product. Far from flawless, but done. Unfortunately, like every project that abuses regressions to create autonomous variables, we have to deal with regression oscillation, which is what happens when suddenly the screen starts shaking between 2 different positions. A lot of what I'm about to get into is merely speculation, as no one's yet to confirm what code actually causes this. But my guess after playing around with it for a few days is that in Desmos, variables can update on a frame-by-frame basis at any time between those frames. Regressions update similarly, but somehow regressions update based on their state 2 frames ago. Normally this wouldn't be a problem because autonomous variables weren't intended in Desmos, but this can become a problem if your regression enters a split state. What this means is that since each regression updates based on a 2-frame delay, we can separate our single regression into 2 regressions that update at alternating times. Since variables can be updated on any frame and are not bound to one timescale over the other, the rate at which these regressions update is almost uncontrollably random, and getting regressions to not behave this way would require frame-perfect input. Once one of the inputs vary enough from each state, chaos theory takes over and the sensitivity to initial conditions pushes each state into a completely different result, allowing you to almost run 2 versions of the game at once. Unfortunately, there's not yet a way to detect or stop this, and due to the nature of this, I doubt there ever will be. So keep that in mind while playing. Anyways, thanks for watching. I'll be sure to put a link to the graph in the description if you want to play.
Wait, can we play the game?
This game.
Oh my!
How
Try
do I
it.
play?
Bro, what the heck? I've given up on trying to understand. What is this?
Oh, trust me, this guy is
No, use the slider. Use the slider. Oh, it's laggy.
I just die.
This seems hard. Oh, it's doing the shaking thing. Why are you so slow?
This is bad.
I want to play.
Just died again. Well, my computer's good. I think I can handle it. My computer's actually kind of good.
Is my computer too slow for this?
I have good stuff. I have a good. Ooh. He has 41 videos.
I'm like speechless how smart this guy is. It's very impressive.
He did Desmos pixel art. Oh whoa. Okay.
This guy can make a Desmo look like
Desmos is a game engine.
nope.
A few days ago, I posted a proof of concept Desmos graph where you could play.
Okay, I can run this. My computer runs this perfectly.
I don't know how to control the guy.
Oh, you can zoom out and it looks weird. many colors there, I swear. Oh my! Yo! That's illegal! That's illegal!
That is crazy.
That's illegal!
He's not only the
It's
good.
not just crazy, it's illegal.
He's
How did you?
he's a amazing. This is a
Oh, day one. Going to day one. What are you doing day one? Can we just see day one alone?
yeah, you can.
Oh. Then day two. Then day three.
I don't think he oh the cutter he just put an image just like last time. So this
Yes, like,
is a
He
cutter.
did a pixel by pixel basically.
Yeah, he just did a cutter back after that.
It's like the image, actual image. And he did that. Oh, that's impressive. There's no way I can do anything close to that. That guy is smart.
No, this guy can make his own Desmos. He's
I
that
feel
good.
he's gonna be a billionaire one day. Like everybody who subscribed to me gets like 1 billion coins. Like what? That'll be cool.
Yeah, so
Unsubscribe.
yeah, it's kind of funny. Like after you see this guy, you're kind of depressed because how the guy is really really intelligent. But
You're like, wow, I made a sunshine. There's like this guy here. Hey, I made an entire game on Desmos.
true, seriously. Not gonna lie, I'm like very very shocked. This is the kind of talent actually exists. But this is actually truly amazing.
I'm going back to Minecraft.
So he does a lot of stuff too. He does neural network in Desmos. Wow, this is
I feel like he's hacking. Like he's literally hacking. No, he's not. He has to be actually.
The idea behind basic neural networks is to give a computer tons of input and output examples, then hope that the computer can find a way to meaningfully relate the two and generalize for more examples. The way it learns a meaningful relationship is through a series of connections between neurons. Each of these connections has a weight which represents the significance of the connection, and each neuron has a bias, which is a number added to the neuron to give it a higher or lower activation. Finding the right weights and biases to get as close as possible to a desired set of outputs for a specific set of inputs is called training, and it uses tons of cool big brain stuff like backpropagation. I'm not big brain, so I just use a JavaScript library called brain.js to do all the training for my networks. If we were to represent our network such that each neuron could be thought of as a coordinate with an X component as its layer in the network and a Y component as its position in said layer, we could say the activation states for each of the neurons in the network could be represented as this. Of course, seeing a giant block of math like this isn't very useful unless you get an intuitive grasp on what it means, so here goes. A neuron at position XY would hold the value of the sum of all neurons in the previous layer, with each neuron having its activation multiplied by the strength of the connection, or weight at position XY for neuron I. After we take the sum of all neurons multiplied by their weights, we add the bias B at XY for the specific neuron we're finding, then wrap the value in an activation function, which in this case is a sigmoid. So now that we have an idea of how a neural network would work mathematically, we still need to actually make it happen. For a really simple example, let's start by training a neural network on an XOR logic gate, then trying to put that into Desmos. Let me just take that. Okay, so you have a trained network now that can fairly accurately mimic an XOR gate. To translate this to Desmos, we can have a list that stores our input and a list for every neuron to define their biases at that certain point. We can then represent each neuron as a variable based on the expression we previously discussed until we reach the output layer. A lot of copy-pasting later, and I ended up with this. The especially cool thing about having a network with a low number of input and output layers is that the entire network can be represented as a function with 2 inputs and 1 output, and hence can be graphed 3-dimensionally. Anyways, XOR gates are trivially simple, so let's make a network that actually does something impressive, like
simple.
recognizing handwritten digits. The MNIST dataset is a collection of pre-classified grayscale images of handwritten digits normalized to a 28 by 28 pixel boundary. What I want to do is convert these images to an array of 784 inputs with 10 outputs for how sure the network is that the image is any given digit 0 to 9. You could do this the much more efficient way of packing every image in the dataset into a single image that could be easily loaded and interpreted, but I didn't feel like doing that, so instead we're gonna pipe DIRSB into a file, then turn it into a JS file storing a multi-line string and use that to load our 42,000 training images individually. A bit of training later, and now we have a network that doesn't completely suck at classifying numbers. Unlike with the smaller XOR network, this network is a little too big for me to just copy-paste values, so instead I wrote a function to convert a set of weights and biases to a list of Desmos expressions. Our network doesn't really look that cool right now, but we can fix that by making a nice little display for our input and a graph for confidence of each number. Another problem is changing our input would require manually modifying values one by one in a 784 length array, so I wrote a program real quick to simplify the process. This lets you draw onto a grid and use the values we created as an input to the network. So, does it work? Well, yes and no. It's able to classify a lot of numbers correctly, but sometimes gets hung up on specific details. This could be caused by overfitting or maybe just a bad architecture. Image classification would probably work much better on a convolutional network instead of a classic model. But, for a proof of concept, it's fairly accurate. Also, if you're wanting to mess around with it, links to the source code, graph, and a live version of the editor are in the description. Okay, finally, thank you all for 100 subscribers. I think we're at like 130 by the time I'm writing this script, 140 by the time I'm recording. And that may not seem like much, but it means a lot, especially since I've been doing this for quite a while now. I know it's cliche, but if you like my content, it would mean a lot to me if you would consider subscribing.
Do you guys see what's going on with this guy?
He's hacking, that's what.
Do you guys know what's a neural network?
No. No, I don't.
Samuel, do you know what's a neural network?
All I know is that he's hacking.
No, a neural network is to be able to recognize everything, like the handwriting, right? A computer had to be able to recognize your handwriting. So if you write 3,
Well, I can't. How can a computer do better than me?
so it's basically a bunch of check and guess of all each pixels, and so this guy could have worked for a company like Tesla. Tesla right now is trying to work on a fully self-driving vehicle, which is they have to look at the image. They have 8 different camera on Teslas, and so Tesla's gonna take a picture of all the surrounding, and they can tell whether that is a mailbox, whether that's a dog, whether that's a human being, it's a skateboard, a tree. So every image you're gonna resort into that one thing. So that's what they call the neural network. So Tesla really work on a big company, like for example, they have a supercomputer in Tesla. It's called Dojo. Dojo is gonna take all this information and training the computer how to recognize the images. So basically in the future you don't need a person drive a car, you just have a car drive itself, which is what you see in the movies. But basically built by this things called neural network. Neural network is basically
What's metaballs?
Huh?
What's metaballs?
I have no idea.
Click on the video.
Which one? Oh, make
Metaballs in JavaScript.
I'm surprised he only have 469 subscriber. This is a insane of stuff. And this guy should working for. This guy is literally enough to work for a company like Tesla, like Apple or anything like that. He can do. He can use a simple Desmo to create his own neural network, which is a force on the YouTube channel. I never seen somebody does this, and I seen some crazy stuff with the 3 Brew and 1 Brown, which is they make a very good video, and even that guy cannot do what this guy can do. And I really wonder how old is he, and because he doesn't sound that old. He
He's in
sound like,
college.
huh?
He's in college for calculus, which means he's probably a freshman in college, which means he's probably only 18.
Yeah, and 18 to be this intelligent is this person has. That's the only thing I can say is super big brain, like a giant.
Actually,
big
he could be
brain.
just like he could be 17.
Yeah, and
He could be even 16. Because
if I have money, I'll invest on this guy. Just how good this guy is.
I need content. Over the past few months, my channel's changed from John Does Stuff to just John Does Calculus and Physics and World History and all that other stuff, then plays Among Us and procrastinates on everything. Transition. Meta balls, wow, they're cool. They're like circles, but they're not circles. They're like sticky and they do all this other weird stuff. Whoa, let's make them. Okay, so like the general idea is imagine this thing graphed in 3D, but then you like add it a bunch of times. And then you multiply it if it's like bigger or smaller or whatever. Yeah, that's it. That's literally all it is. And then you just intersect it with a plane. Wow, look at this cool drawn out demo. Coding time. So I started off with this default template, canvas, everything that you would need. There it is. It's already setting its width to 500, height to 500. What I first need to do is
Samuel, what is
probably
he
make
coding
a
with?
function
He's
for
doing
distance. Yeah, or magnitude over
Oh, no,
distance
that's-
squared.
it says
And it can be
JavaScript.
magnitude.
Looks like
Each
HTML.
metaball can be stored as an object. Add 25 for now.
JavaScript is just
We
Java
can set
better.
these all to math.random. And then each time we would want to render, we could call a render function. Iterate through metaballs. Image data equals that. Then we can just iterate through each pixel and image data. Some metaballs XYZ. And not XYZ, XY metaballs.
It's pretty different.
Ooh, that's because I'm an idiot and I put it into here. Wrong parentheses. And that would get us... nothing. Nice. That never happened. None of that ever happened. That never happened. I did not forget to set my alpha channel. I am smart. And...
He
yeah.
has our sense of humor.
I mean, it's gonna go as fast as it
He's
can.
pretty funny.
Because this is single-threaded, so...
Gaming calculus.
A few days ago, I posted a proof of concept Desmos graph.
We already did that.
You know what? I can play Minecraft better than him.
I don't know about that. I think
I could. I am top like.
I think this guy is definitely a different.
I refuse to believe he's in the number. He's in the top 100 above me.
He's a.
I refuse to believe that he's better than me in that.
I don't know. I think. How is it you only have 469 subscribers? I don't understand.
Because he wants 69 subscribers.
I really don't understand. This guy is just truly. And he got a good sense of humor too.
Joe. He's a weeb.
He's what?
He's a weeb.
What is a weeb?
Oh, never mind. Destroying Nerd that Snake. Destroying Nerd that Snake. I want to watch that. I want to watch Destroying Nerd that Snake.
He actually participated in global math Wait, is it 38 minutes?
Oh, that's a cube thing. Mod. Y equals Y equals Y equals. Ow! Is that you?
What happened?
Is this drawing competition, Donald Ye?
No. Yeah, that's the YouTube.
He's streaming.
Yep.
He's streaming! I want to find the YouTube channel.
You cannot find it.
What? Wait, what?
He's streaming! He's streaming!
Wait, yes.
Where I'm in his stream. I'm watching his stream.
Oh
Wait,
yeah.
what's the channel called?
It's called Donald Ye.
What?
I'm seeing his stream right now. It's so delayed.
It's just called Donald, yeah?
Yeah.
Yeah.
I'm watching his stream. Quality content.
Wait, no spaces?
What's one space? Streaming. I hear myself. I hear myself. Oh my god. What's the channel called? What?
How do you
Oh my
get?
god. It's literally, I can hear myself like from a minute ago.
Yeah.
I can't find it. This is mean.
You're bad. It's called
I am bad. Where is it?
I'm watching it right now. I'm sending you the link.
No, Discord is. Oh, wait, never mind. Yeah, just wait. No, Twitch. Twitch is blocked on the computer.
In chat. I'm sending it in chat.
How is
On
it?
you? Wait, he's not on YouTube?
How is it? How?
Yeah.
Oh, he's live on YouTube. Oh. One watching. Can we hear that one?
I'm watching it right now. I'm sending you the link.
No, Discord is. Oh, never mind. Yeah, just right now. Twitch is blocked on the computer.
How is a computer block Twitch? How do you block Twitch?
Are you on the stream?
No, like I'm on my school computer.
Are you
and,
on
like,
the stream? Are you on the stream? Yes, are you on the stream?
I just figured out how to do them.
Yo! He has followed!
How is the computer block Twitch? How do you block Twitch?
Do you